Hi everyone, I'm Tim Wang from Tsinghua University, and I will introduce the eMarketing China and China models. First, I will introduce the background of the modeling work. The eMarketing China belongs to a top-down model, or simply called TD model. As a general equilibrium model, eMarketing China can represent the input-output relationship among different economic sectors suitable for macroeconomic analysis of climate policy, including carbon tax and carbon markets and so on. As we know, the CGE model describes the substitution relationship between inputs based on electricity. But this substitution relationship is not achievable in actual world, especially considering the limitation of technologies. That's how the industrial process CO2 emissions and non-CO2 GHG emissions are usually characterized based on the values of sectors in the CGE model. So it can cause a low accuracy when concerning the projection of these gases. The China Mall model is a bottom-up model, or simply called BO model. Compared to the eMarketing China model, China Mall is technology-rich side. Technical substitution are highly reliable compared with eMarketing China. For the demand exogenous, China Mall lacks reflecting the socio-economic structure via the partial equilibrium structure ignores the rebound effects and the intersector impacts. So considering the advantages and the disadvantages of these two models, we also attempt to link these two models to combine their advantages and avoid the disadvantages. Then I will introduce the China Mall model. At the bottom of China multi-gas optimal reduction evaluation model, it is written on the TIMES VEDA software. The detailed structure of the China Mall model is shown as this figure. In the model, the CO2 measuring the nitrogen and F gases emissions and mitigation technologies are all detailed modeled, especially the electricity dispatch modular is well modeled to represent the challenges for variable renewable energy deployment. Then I will simply introduce the key sectors modeling model. The building sector includes three subsectors, including rural, urban, and public buildings, and six major energy service demands such as heating, cooling, cooking, heating, and hot water appliance are all described on each subsector. The transportation sector maps passenger and freight transportation needs of railroads, roads, waterways, and airlines, and other transportation technologies. We also map the future zero carbon technologies such as BEVs, PHEVs, and so on to build the deep mitigation technologies in the transportation sector. The industrial modeling include steel, non-ferrous, non-metal, and a lot of detailed industry sectors. The power sector modeling and the long CO2 GHG emission projection are another focus of the China Mall model. The power sector describes the size, technology type, installed capacity, this kind of technology variables, and this investment cost, fixed cost, and this kind of economic variables of the coal power unit in China in a very detailed way. We also provide careful portraits of the renewable energy output curve, electricity load curve, and energy storage technology. For the long CO2 GHG emissions model, we update the survival curves for air conditioning and commercial refrigeration equipment. We also update the dynamic long CO2 emissions factor related to these factors and expand the nitrous oxide emission reduction based on a survey of the latest literatures. As we introduced in the background part, the Imagine China model and the China Mall model have complementary advantages. Thus, we also attempt to link these two models. In the Imagine China model transfers the macro results, including GDP sector output, to the China Mall model as input. And the China Mall model transfers the energy system optimization results to the Imagine China model, including energy flows, volumes, price, emission factors, and carbon price is kind of information to the model. Then we just run these two models together until we get a converged status. Finally, I will introduce what the Imagine China model and the China Mall model can do and cannot do. First, these models can simulate China's energy and economic transition pathways for specific emissions targets. Actually, these two models are well designed for the analysis of China's carbon neutral targets. We also can use these two models to assess the economic cost of achieving climate goals and evaluate the impacts of key factors such as energy cost changes and the negative emissions technology developments on the achievements of climate targets. However, the models also have some drawbacks. They are weak in doing global analysis. For these two models, both concentrate on China. Meanwhile, these models cannot do cost-benefit analysis of climate policies right now, for we don't assess the damages in these two models. But we are not put forward these functions, and we hope these two models can do the cost benefits of climate policies as soon as possible. So that's my presentation. Thank you for your listening, and questions are welcome.